And welcome to episode 6 of Unsung Heroes of the Cloud. Today we've got our guest, Phillip. Hello, welcome to Unsung Heroes of the Cloud. Today we've got our guest, Phillip Gibson, with us, and he is a senior PM on the Azure open source Upstream security team, and he'll be rolling up an AKS cluster from scratch to show us some of the new projects they've got going on. And we've also, of course, got Mike and Nils. Welcome, everybody.
Hey, hello, everybody. And thanks for joining us, Phil. But before we get to you, Phil, how are you, Mike?
There we are. It took a while. It looks like the stream is not with us today, right? So, how's everybody doing? How are you doing, Niels, this week?
I am doing perfectly fine. I'm looking forward to grabbing some beers outside of the house later this afternoon, so I've got good plans today.
Ooh, that's something to look forward to. And anything else exciting happened the last 2 weeks since we've seen each other? Or
well, this weekend I bought a new car, so that's sort of exciting.
Mr. Fancy Pants, nice.
Yeah.
That's always nice.
Call her Miss Fancy Pants because my wife's driving it.
Okay, yeah, okay. But she's entitled to. I mean,
yes. How are you, Mike?
I'm good. I was a little bit lucky because this morning I felt a little bit under the weather because I'm finally shot, and don't mean by caliber 9, but I got my vaccine in one shot only. It's a it's a J&J vaccine, so I only need one shot. So I'm very relieved that I can finally put some of this misery behind us. And,
yes.
Nice.
Let's welcome our guest today. Hi, Phil.
Hey, how's it going?
Pretty good. Excited to have you on today.
Yeah, I was going to ask you, what's the insurance cost on that new Lambo you bought?
Okay, and on that bombshell.
Yeah.
Oh, I'm sorry, I didn't want to put you out there.
No, all good. So, Phil, why don't you tell our audience a little bit about yourself? What do you like to do for fun?
Yeah. Hey, everyone. My name is Phil Gibson. I'm a senior PM here with the Upstream open source team here at Microsoft on Azure. And one of my craziest passions since I was a kid is I like to barbecue, man. I'm kind of it's technically not a foodie. I was told that I'm not a foodie. I just like to cook protein. So I don't I don't actually consider myself a foodie, but I do like the art of smoked barbecue, and so that's been a passion. So if you follow me on Twitter, I'm always posting kind of like my competition ribs and my competition brisket, etc. So that might be the second phase of my career here.
So what's your weapon of choice? What kind of grill you have?
Oh man, I got a variety of smokers out there.
Of course.
I won't name brand, but I got the vertical stuff, the horizontal stuff.
Kamado?
I've had one of those. I've gone through, the green egg and all of that stuff, but I've settled actually, and some of the purists might beat me up for this, but I've settled on some pellet grills, which I like. The purists are, what we call like the offset stick burner stuff, and I could definitely do that if I have those. But just the set it and forget it lifestyle of a pellet grill. That's a thing of beauty.
I've never tried it. I mean, I heard about it, but I only came across it last year for the first time. As long as it isn't in a gas barbecue, all is fine.
No, it's not
Mike,
gas.
I am going to have to admit, I have a gas barbecue here because the apartment complex where I rent doesn't allow charcoal, so I had to get a gas barbecue.
But that's a different story. I mean, if you're doing it on a terrace, it's kind of hard, and then I can understand because elsewhere you will smoke out the entire building. That's not gonna happen.
I will say, talking about barbecue, I do love, as a European transplant in the US, the US barbecue culture is so different from the European one. The US is really about long time on the grill, really get the meat tender.
Yep.
It's a little fattier meat, but because it's on the grill for 16 hours, all that fat renders into the meat. And oh my God, Phil, I can't wait to fly to Atlanta and just get your brisket.
Ooh.
Absolutely. Anytime you hear, I'll throw one on the grill, and there's just tons of spots too. Here,
Yeah.
obviously, I'm in the southern part of the state.
We're gonna keep
so,
you up for that, man. We're gonna keep you up for that.
Let's do it. Let's do it.
Before we get into it, there's one thing I wanted to highlight, Phil, because you are a PM in the Azure team, but you are not in Redmond. So
Yeah.
that's actually pretty exciting, I believe, that we're also hiring people outside of Redmond that do cool jobs in Microsoft.
Yeah. It's funny you mentioned that. So here in Atlanta, one of the newest engineering campuses is being opened up downtown. And so a lot of these we would call classic positions at Microsoft PMs and engineers that are associated with products that we create. We're now bridging out into these new engineering campuses that are popping up. So I think the one here is going to open up maybe sometime early spring. I know the building is built, the Microsoft sign is on it. So it's pretty exciting, but we're looking forward.
We only announced that in September or something, right? Didn't we? Like last year?
Yeah, maybe publicly, I think, but yeah, no, it's a beautiful building. Obviously, it's brand new, so it's super eco-friendly and everything, and it's going to be a lot of community space, so it's not just for Microsoft. We're going to be inviting the Atlanta community in and doing training sessions, etc. So it's going to be fun.
Pretty cool.
It's cool.
Pretty cool.
But let's get to the meat and potatoes of our presentation, Phil. What's your unsung hero of the cloud?
Yeah, look, I'm just totally excited to be a part of this. And today, my position here on the Upstream team is I actually PM a lot of our what we call our security projects in the open source world. So today, I'm going to showcase all of our open source tooling that has made it into the Azure platform, specifically around AKS, because we do just kind of concentrate on the cloud native space. So I think it's going to be interesting. I think it's going to be fun for people to kind of see these tools.
Take it away, man. Come on, you're making me anxious.
All right. Yeah, let's do it. All right. So let me spin up the screen here. Let me go ahead and share. And let's see where we're at.
Waiting. Drum roll.
Oh, okay. Sorry. There we go. All right. So hopefully I'm broadcasting now. We're going to fly through this. Again, I'm not here to beat up anyone with slides. I don't like doing that. I'm a real tech. I'm still a geek. But I think everyone knows me. So we're going to kind of cruise through a lot of this and then really get into the meat. But one thing I do want to say is, again, our position here at Microsoft is, we'd love to, as far as cloud native is concerned, we love to kind of look at the gaps of functionality that may be needed. And then we love to build these tools with the community. It's really, it's just really good to get that feedback loop from the community when we put these out there fully transparently, and then we get customers say, hey, I wish it could do this and that. So we're super nimble in this approach, and then obviously the Azure platform gets the benefit from this. So today, let's kind of go through, again, we're going to build an AKS cluster, and then these are kind of the projects that we're going to kind of build up, one by one, and kind of show you the features and functionality. And you'll see as we go through this how more and more secure and stronger your security posture becomes. So with that, let's kick it off with Gatekeeper and kind of introduce people to the Gatekeeper project, if you're not familiar with it. What we're going to do is we're going to basically deploy out. This is our cluster here. So let's just get this out of the way. So let's create an AKS cluster. And so we're going to just create some variables here for our resource group where it's going to be housed, the location, which East US 2, which is maybe 300 miles from the house here.
So nothing specific there, just standard AKS and resource group creations, right? So nothing
just
fancy.
Standard stuff. The beauty here is kind of like this next command. So I'll highlight it and I'll just pause here. So this is kind of like the Uber, upstream Kubernetes build here. So what you'll see here is if you look at the enable add-ons parameter here, you got your Azure policy, that's your gatekeeper. Then you have your Azure Key Vault secrets provider, that's the CSI Secrets Store. And then you have open service mesh here on the end. And obviously,
my favorite.
we'll talk about, the new service mesh there. And then you also have the enable pod identity. And so that's the Azure Managed Pod Identity project itself as well. So again, here's the command in all its glory. We can share this with everyone. And then with the magic of television, I guess, or YouTube or video, we're going to deploy this cluster out in less than a few seconds.
Cool.
So that's going to kick off.
Well, while that cluster was creating, Phil, I know that some of those solutions have Azure in the name, but I know that they are actually part of the community, because I believe that
Correct.
The bulk of the projects you mentioned are actually donated to the CNCF, aren't they?
Yes. So all of these projects, outside of the pod identity, because that's very specific to using Azure AD, every one of these are in the community. They're CNCF projects, and that's where they were birthed. So again, what we do is we kind of look at the gaps out there. We see where friction is, and then we kind of imagine, hey, what can we do to solve this from a lot of our customer feedback, kind of make things a little more streamlined.
Yeah, you said enable pod identity is more on our AKS side. Do you see it happening that we take this along with Arc and we actually inject it like that into clusters that we don't own?
Yeah. So we are actually working on just let you know, I'm just getting the identity and just showing you the list of add-ons to verify. But yeah, so we are actually re-architecting the pod identity model. Today, it doesn't use OIDC. And so we've decided kind of for the future of it, for it to be a little more durable for a lot of scenarios that customers are coming from us, is we're going to start to adopt the OIDC model. And so that's going to make it super flexible. If you're not familiar with the OpenID Connect, it's pretty much what everyone uses for a lot of identity authentication. So that's going to be able to have you have a pod that can talk to anything even outside of your own Azure tenant, as long as you have that federations in place.
That's pretty cool. Yeah.
All right, so that's it. We got our cluster. It's vanilla, but it's loaded with all of our add-ons. And so now let's kind of just go through each of these. So the first one I want to introduce people to, if they're not familiar with it, is what we call Gatekeeper. And so there's been an open source project out there called Open Policy Agent. It's basically a enforcement engine specific for Kubernetes. And what Gatekeeper does is we've kind of extended that policy agent and policy engine to include admission webhooks. And so the beauty about using admission webhooks is we can actually prohibit things from being deployed to your cluster based upon a certain rule set. And so what you're seeing here is in that top, the bottom right is we're going to basically deploy out a constraint. And then what we're saying is, hey, you must have a label that says Gatekeeper. And so when we deploy this out, then any pod that you deploy, if it doesn't have a label that says Gatekeeper, then it'll actually get denied. And so it won't even enter into your cluster. And so that's the real cool thing. Now what we've done with Gatekeeper on the Azure platform is we've integrated this with Azure Policy. And so now all of you, if you're familiar with Azure Policy and how you can do like these enforcements and things within your Azure landscape, now you can extend this into the actual cluster as well. So very familiar tool, Azure Policy, and now you'll be able to put policies on your actual AKS clusters. So with that, let's go ahead and show that. So again, we got our cluster. It's already up and running. What I'm doing here is I just kind of like to open up with just some smoke tests, what we call just some validations here. So we're just going to look at all the pods that says Azure Policy. So you'll see that we have our Azure Policy pods on the cluster. And then we're going to look at the pods in the Gatekeeper system. So these work hand in hand in passing off data and information. And then if you have this all wired up, you'll have what's called constraint templates. So this is a Kubernetes construct. And those are all of the Azure policies that are ready for you to kind of manipulate and use to kind of lock down your cluster here. And so what
they're
I'm
not
gonna do
applied yet, it's only the availability here, right?
Yeah, these are
Okay.
what's available. And this list is constantly growing. You know, as we get a lot of feedback from customers, we'll kind of create more new policies here. And then what we can do here is what I'm showing is I'm just kind of doing a query of Azure policy of all the policies that we have in Azure that are related to Kubernetes. And you'll see that this list comes back and it's a pretty long list. So this is pretty cool. Again, if you want to kind of do all these controls and lock down your cluster, there are tons of Azure policies at your disposal to do so. Now, what I'm going to show you here next is what I've done for this demo is I've put two policies on this cluster. And so we'll just query what this cluster has already been targeted for. And so you'll see we have the Kubernetes cluster should not allow privileged containers. So that's kind of a no-no. You don't want the process to be container running as root. And then the other one is Kubernetes cluster containers should only use allowed images. And that's really controlling where the images are coming from that you're actually deploying into your cluster. So for the allowed images, I've set that up to where we can only allow images from the Microsoft Container Registry. And so I can prohibit, any other images that may have, malware, ransomware, etc. And so this is easily configurable by a regex command. And so now that that's in place, let's go ahead.
Not fair, you said easy.
Yeah, it's relative, right?
Just messing with you.
I grew up on regex, so that was like the language to do. But yeah, let's kind of test this out. So let's go ahead and get our infamous busy box, and you'll notice that this is coming from Docker Hub. And immediately when I try to deploy this onto the cluster, I am denied. So you'll see that, hey, this feedback here saying, hey, this basically violates one of the policies that you have. So not good for you. You're not going to get that onto the cluster.
This is awesome. This is awesome with DevOps gating, right? I mean, this is exactly what you need to avoid stupidity between brackets. Now, but because that's the thing. We need to do more shift left, and they should be able to scan and take a look at the correctness of their images when they're building Docker images or container images. And this is perfect to avoid that they get either in production or even, that's pretty cool, man.
Yeah. We've had many instances of some closely named popular images that someone unknowingly did not know about, and they got malware in and got, it was a mess. So a policy like that, you can say, hey, this is only our custom registry, and then these known like a Microsoft registry, etc., are only allowed to be deployed into the environment. This next one here, we're going to show you, if you see kind of in the spec there, you got your security context, and this is privilege true. And so again, this is a policy that we're prohibiting any container from running as privileged process. And then immediately again, because that security context is privilege being true, it's going to be denied. So you're ensuring that no container or pod that's running in your environment will run under kind of a root access process,
Pretty cool.
Yeah. So then to sum this up, so here is a legitimate pod spec that it's not privileged, and it's coming from the Microsoft Container Registry, and you see that immediately was able to be created with no issues. So again, nicely tight control policies with the addition of Gatekeeper and the Azure policy integration there.
I like this. I like this a lot. Yeah.
And Phil, just to confirm it, you now said I want a policy to only be able to pull from the Microsoft Container Registry, but you could change this policy as well so that customers can reference either their own Azure Container Registry or their own even custom registry that they're hosting themselves on GitHub.
Correct. Absolutely. And in fact, when we get to the Open Service Mesh demo, you'll actually see that when I deploy out the bookstore application, it's coming from a different registry. So you actually see me update this policy to include that additional registry that I'm enabling.
Cool.
So that'll be
pretty cool.
Yeah. All right. So the next we got on tap is the Azure AD Pod Managed Identity. And what's nice about this is, again, if you deploy a pod into your cluster, it really doesn't have an identity, right? And you may want that pod to, again, if you're working with AKS, you may want it to actually interact with other Azure services, right? So in this example, we're talking about Azure SQL Database. To do that without this pod managed identity, you would have to kind of bring that authentication logic into your code base, right? And so there's a lot of people are doing this. It can be cumbersome at scale. You may have changes on endpoints or changes to the actual Azure service that you want to interact with. So that's just another portion of your code base that you're going to have to keep up with. With the Azure AD Pod Managed Identity, what we've done is we allow you to kind of load identities onto your AKS cluster. And then for the app dev person, all they have to do is kind of reference in their pod spec this kind of app, AAD pod binding label to get that identity, so that pod will actually assume that identity. And then from there, it's just your normal Azure RBAC and controlling what that identity can do in your Azure environment, right? So with that, let's kind of go ahead and set this up. Again, we're starting from scratch here. So again, we got our cluster deployed. We got Gatekeeper on it. Now we're going to go ahead and set up the Azure AD Pod Managed Identity. I'm just going to create some of these variables here. What we're doing is, again, we're just going to create a resource group to house these new identities. And then we're creating two identities. So you'll see one is Upstream Test Identity 1 and Upstream Test Identity 2. We're going to basically allow Identity 1 to access a key vault, which we're going to deploy here a little later. And so here we go. We're going to go ahead and create that first identity there. And then as soon as that finishes, we'll create the second one. And again, so these are just Azure AD accounts that we're just creating. And then ultimately, we're going to associate this with the actual pod that's being deployed in your AKS cluster. So now that I have those identities out there, I just need to grab some like client ID and resource ID, because I'm going to be using that to actually do some of the RBAC in Azure, specifically for the key vault that we're going to spin up. So again, I'm going to have Identity 1 be able to access not only key vault, but also a secret that's inside of key vault as well. And so we're just, again, grabbing those resource IDs and client ID and so on there. The next thing we have to do is, now that we have these identities, we have to add them to the AKS cluster. So what I'm doing is I'm getting the node group of my AKS cluster. So that's kind of where the VMSS scale set is. And I'm grabbing that ID, and then you'll see this new role assignment called a managed identity operator. So this is very specific to this functionality. And so we're going to basically, those two identities we created, we're going to give them the role of the managed identity operator onto the node resource group where your AKS cluster lives. And then from there, what we do is now we have to then add what's called a pod identity resource here. So again, I'm just grabbing the names of those the two that we've already created. And then we're going to then make sure that we're mapping those identities to the pod identity that's going to be used. I'm saying pod a lot. So,
that's okay.
Yeah, there's a lot. But yeah, so essentially, hey, put these identities onto your cluster, and then we're going to create these pod identity attributes, so to speak. And you'll see that we're having these propagate. And so the first one's done. And then we're going to do that for the second one. Again, it's the AKS pod identity add. So again, we're kind of just mapping those identities to this project to use for the labels.
And Phil, when we're talking about pod identity, I know that this is now using the add-on. If
Correct.
you use the open source version, correct me if I'm wrong, but then I believe that in the open source version, you can't use the Azure CLI, and there's a number of steps that you manually have to take, which the add-on simplifies for you, and you just use a one-liner to get that link to your cluster.
Absolutely, yeah. If you as we were building this and then testing it, one of the biggest complaints is, hey, there's a whole laundry list of items. There's tons of CRDs and all these ads that you have to do. But again, we've completely streamlined this process now with the add-on. It's just added as an add-on. All the magic happens, and you're just faced with just loading up the identities that you want to use for your pod here, which we're going through at this point. So yeah. So now let's go ahead, and now that I have those identities, those AKS pod identities, I'm just going to list them out just to show you what's on the cluster to use for your pod manifest. And you'll see we got the upstream test identity 1 and then upstream test identity 2. Next, we're going to deploy a brand new Azure Key Vault. So again, we're just loading up the variables, what its name is going to be, the resource group it's going to live in, and its location. And we'll go ahead and just create that group real quick. And then these following commands is just us actually, one, creating the Key Vault itself, and then 2, we're going to actually create a secret in that Key Vault, because what this is going to demonstrate is when that pod comes up, that it can actually not only access Key Vault, but then pull a secret out of Key Vault. And then again, you can use that in your application, however you want to do that. And so we'll go ahead and create the secret, and it's called secret 1, and its value is just hello world. So that's kind of the normal learning to code type of thing there. And so here we go. I'm just going to build up the Key Vault variables that I need just for the group ID and everything, just so I can now assign those previous IDs to it. So you'll see that I'm only going to assign the identity 1 to have access to this Key Vault, because then we'll show you when we spin up identity 2 and we try to access Key Vault, you'll see that it's denied. And then in addition to that, Key Vault has this extra set of a policy that you actually need. So not only just access to Key Vault itself, but if you have a secret, you actually need to set a policy allowance or access to that secret as well. So I know that was a lot, but now we're ready to do some testing. Right? So the first thing I'm gonna do is I'm gonna run just inline. We're gonna spin up a pod, and you'll notice that we're using identity 2, and identity 2 was not added to Key Vault for access. And so now that I got that pod and I'm exec into it, I just need to create a variable here of what my Key Vault name is. And so now I'm actually in the pod. So you'll see I'm at the bash command there. And then I'm going to do an AZ login -- identity. So I'm just going to assume the identity of this pod. And then now I'm just going to do an AZ Key Vault secret list. And you'll notice that, hey, I don't have access to this Key Vault, which is correct. We never assign that pod identity for that particular pod to access Key Vault. This next one, we're going to do identity 1, which we did go through with all the RBAC permissions to access Key Vault. So similar task here. We're going to run this pod. We're going to exec into it, and we're going to just build the variable here to access the Key Vault name. And then we're going to do our AZ login. And again, this command here is going to assume whatever the identity is of this pod, which from the label is going to be that identity 1. And now when we do our secret list to that Key Vault, we now have access to see that secret.
Nice.
So again, no authentication logic inside any of my application. Yep. This is all done with controls right on the AKS cluster.
So no Pretty passwords cool. To manage, no certificates to rotate, just use.
Yep, that's it.
That's the way it should be. Yep.
Yeah. And so then the question we get is, hey, well, if you're giving access to this pod by a label, can't anyone just put the label on it? And that's true. So in that case, you want to, again, work with your normal, Kubernetes RBAC permissions, as well as using Gatekeeper. And so Gatekeeper has a policy to where you can say you can't deploy based on a label, or you can deploy based on a label. So there's a lot of ways that we can actually put some process around this to ensure that no one can kind of hijack the label that you use here for access.
Yeah. Pretty nice.
Yeah.
Well thought of, man. Really.
All right, so the next what we got going on here is CSI Secrets Store. And this normally works in conjunction with Pod Managed Identity. Basically, if you're familiar with secrets, how they work with Kubernetes is you have a Kubernetes secret. That secret stored in the cluster in the etcd, and it's only as secure as you basically doing the base 64 decoding, right? So it's not secure at all, so anybody that has access to those secrets, it looks like it is encrypted, but you just decode the base 64 and you'll see whatever that secret is, kind of plain text. So what this project does, and why a lot of people really like this, is what we do is we now move, if you want to use secrets, we kind of are still kind of using that process, but we are moving the secret outside of the cluster, and we're actually storing that secret in Azure Key Vault. So as far as your pod is concerned, it thinks it's just grabbing a normal Kubernetes secret, but it doesn't realize that it's actually fetched that secret outside of the cluster. And then two, the way that the CSI Secrets Store works is obviously the storage involved that we're using is actually a temp DB. So we're actually mounting like a RAM drive. It's an ephemeral drive where the actual key is stored, or your secret is stored. So it only has the life cycle of the pod. It's not stored at rest anywhere on the cluster. So very, very secure way
cool.
to do secrets here. Yeah. So let's show this again in conjunction with Pod Identity. What we're doing here is we're going to get our Key Vault name and, a little too fast there, didn't I? Whoops, sorry about that. We're going to get our Key Vault name and our pod namespace. So because we've already set up Pod Identity, and so what we're going to actually do is we're going to use that Pod Identity to then access Key Vault to then load the secret into the memory of the pod itself. And so what we're showing you here is just, let's look at the Secret Store add-on being deployed. And the first thing we got to do is we got to create what's called an Azure identity for the cluster. And so that kind of binds it to get access to Key Vault. And then we're binding now that Azure identity here. And again, this is being all binded to the actual, that first account that has access to Key Vault. And then we create what's called this secret provider class. And you'll see that its provider's Azure, it's using Pod Identity, and we're specifically saying you can access this Key Vault and this specific secret that Key Vault has using the Pod Identity that has the label for the pods, right? So you can be super granular on how you do this.
That's cool.
And then
how would you manage multiple secrets and potentially multiple key vaults? Would you create multiple of those provider classes?
Correct. Yeah, you would just create a provider class specific to that Key Vault, and you can create multiple of them as well.
Okay.
So yeah,
so it's not per application; it's really per Key Vault that you're gonna do one. Okay, pretty cool.
Okay. Yep. And then here we're just gonna show we got our secret provider class listed. And then here what you'll see is, again, we're going to create this pod. And again, that pod just needs this Azure AD binding. And so we're binding to that identity that's going to be used to access Key Vault and build the secret. And then a lot of this is just kind of the plumbing that's needed for it to mount the secret. So you'll see that we got some volume mounts, etc. And so we're going to go ahead and deploy this out. And so now that pod is created, we'll go ahead and exec into it. And so this first command is just to show the mount being there. And so we'll run this, and you'll see that we mounted it, and secret one is what we call the secret in Key Vault. The next one is now we're going to see what's in that file. And there it is, the hello world. And so that was the value of the secret that's stored. And again, this is all in RAM memory. It's a temp dir. So again, it's not sitting on your cluster. No one can just go access it. It's just there for the life cycle of the pod itself.
And if I can ask one question, Phil, a lot of my customers don't use secrets as a mount. They actually use those as environment variables.
Yep.
Is it also possible to use environment variables rather than a file mount with the
Yes.
CSI driver?
Yep. You can actually use the environment, the envar as well to do this the same routine here.
Oh, cool.
That's all allowed. Yep.
Nice.
Yeah,
That's
the
useful.
secret provider class will, it has all that functionality. It's well documented. It'll tell you which options are available for you to do.
Nice.
All right. So we're going to end here with kind of one of our newer projects, which is
My favorite.
Open Service Mesh, right? And again, this is CNCF. We've donated this. We're kind of in an incubating state. But again, our whole vision with this is let's just keep this thing super simple, boring almost, right? And then it does kind of like what we say, the 80-20 rule. It does the majority of what people want a service mesh to do, which is to provide traffic access, as well as MTLS between their service endpoints. So we're going to jump right into the demo. I just want to do a preview of what you're going to see, because we're going to see a bunch of text flying back and forth. But what we're going to do is we're going to deploy out a bookstore application. And then that's going to deploy out, this book buyer and this bookstore V1. There's a book warehouse that gets deployed as well. And then we're going to onboard those namespaces to OSM. And we're going to be in this what's called a permissive mode, being true. And that's going to allow us to basically deploy the Envoy sidecar and still keep the normal communication going. When we flip the permissive mode to false, you'll then see that we're going to be required to have an explicit rule for OSM to pass traffic between the two endpoints that you want. And so that's going to be this traffic target that we deploy out. And then that's going to restore the communication between the two. And then we're going to just end with a demo of a traffic policy split, which means we're going to deploy out the second instance of the bookstore V2. And then we're going to change the weight between which bookstore the book buyer is buying from.
Nice.
All right, so let's go ahead. Oops, sorry. Oh, I think I forgot I was on the same slide there. Let's kind of go back, and here we go. So what we're going to do is we got our AKS cluster there. We'll just do a quick query to show that the OSM add-on is part of the cluster. And then again, I call this kind of like our smoke test. We're just going to test and see the deployments for the OSM controller, the pods that make that up, as well as the services in the kube system. Because again, this is all part of the managed AKS service. And so you'll see we have the OSM injector, the controller, and the validator. And then we're going to take a look at this config map. And the config map has some of the configuration that you would do this today. Just to let everyone know, we're actually moving away from a config map. We're going to have this as a CRD, so it'll be even easier to configure.
Nice.
But what I've just highlighted there was showing you that we're going to be in permissive traffic mode being true, which means, again, for your brownfield environments, oh, let me just pause here. So again, I think, Niels, you were asking about the addition of this other registry.
Yes.
And so there you see. So again, I'm just piping, and I'm now saying, hey, you can now bring in containers from this open service mesh, which is basically Docker Hub here at this point.
Okay.
So we have that gatekeeper policy updated, and then now let's go ahead and deploy out this bookstore application. So the first is the book buyer that gets deployed. Second is going to be the bookstore that's going to get deployed. And then last is the book warehouse where all the books are. And that's going to get deployed as well. And then we're going to show, we're just going to get everything in the bookstore. Just show you everything's running here. So we got everything's up and running. So good. So now what we're going to do is let's go ahead and kind of query on the book buyer pod itself. And then we're going to tell the logs coming out of it And you'll see again, we've not done anything with OSM at this point. And we're going to show the logs, and it's just basically showing the book buyer is talking to the bookstore endpoint, and that's the bookstore v1 service. And you'll notice that server attribute is NA, because that means there's no Envoy proxy involved. It's just talking directly to the bookstore endpoint. Next, what we do is now we're going to add and manage these namespaces with OSM. And then just real quick to show you that that pod is just a single container pod. And now that we're managing these namespaces with OSM, all we have to simply do is do a restart on all the deployments. That's now going to instruct the new creation of those pods to get the Envoy sidecar injected into them. And so when we look back at the new book buyer pod here, you'll see we now have a 2 of 2. That should be coming up.
But then, Phil, just to confirm, if I were to create a new pod, on new pods and new deployments, that would automatically be injected.
Yes. Once you manage, once you onboard the namespace, all the annotations are there. So any new pods will automatically get the Envoy sidecar injected into them. That's correct.
Cool.
Yeah, this is more like a brownfield experiment, because a lot of people may already be running things, and this is kind of showing you how safe it is to actually test out OSM in a live environment. So now we see we have the 2 of 2, and then again, if we just query onto that new book buyer pod that's been deployed, and then we can do a describe, and then we can kind of walk the manifest here and show the addition of that Envoy sidecar proxy. And so we'll scroll up and you'll see, hey, there's our Envoy sidecar. And then we have our book buyer. So that's your application. And so now if we tail the logs of this new book buyer pod, again, we've not put any policies out. We're still kind of in permissive mode being true. You'll now see it's still talking to the bookstore endpoint, but now you'll see the server attribute is through Envoy. So now that traffic is traversing through the Envoy sidecar proxy. And so now we're going to do what we want service meshes to do, which is to really control the traffic. So we're going to update that config, and we're going to turn it to, got a bad finger or something. So we're going to update this, and we're going to turn permissive mode to being false, meaning now you have to instruct OSM to have explicit rules to pass traffic between the endpoints. And we'll go back and just simply tell that book buyer pod again, and now you'll notice that, hey, we're not allowing you to talk to the bookstore, right? So let's bring that back. So this is a traffic access policy. We'll simply just deploy that out. And once that gets deployed, we can go back and take a look at the logs of book buyer. And now you see we're back up and running. Yeah. Again, with the policy.
That's pretty cool.
Yeah, so that's nothing else can talk to the bookstore other than the book buyer, what we've instructed it to.
No. So there's no need to restart Envoy as you push new policies. That's all runtime directly done.
Exactly, yeah. We update the OSM controller. That sends out the new information of the program, the proxies, and that's all done in real time. Yep.
That's pretty neat. Cool. So does this guarantee a secure connection between all these services then?
Yeah, because it's MTLS. So what we're saying is we're basically deploying a certificate. So there's a CA bundle inside of OSM. We're actually working to allow you to bring your own CA as well, so you can deploy your own certificates. But they're going to get their certificate, each service endpoint, and then that's going to be MTLS encrypted. And so it's specifically looking to say, hey, do you have a cert? And then also, does the policy allow you to talk to this endpoint?
Because that's the thing that a lot of people don't know, that with a service mesh that you actually have some end-to-end communication encryption and some protection on that level. So hence why I'm asking the question, because this is something that people should be aware of.
I might have another question, and you can blame me for my ignorance, but what the hell is MTLS?
So that's your mutual TLS, right? So that's basically ensuring that your identity is real, and that's what the mutual part. So we have TLS, that's like client side to say you hit your favorite website, you get the little lock. So that's your TLS saying that, hey, the endpoint that you are hitting is verified from some identity. When we add the MTLS to it, what we're saying is that, hey, I also know about this other identity. They are who they say they are too, and we're going to pass you to another identity that I also know is who they say they are, and then we're going to allow you to communicate.
Okay.
So that's what the MTLS does.
When I've played around with TLS before, or SSL as it was called before, managing certificates can be really hard. What I saw you do seemed very simple. Is there anything for me to manage with those certificates, or is it all abstracted away and OSM manages that for me?
Yeah, it's all abstracted away. So all your certificate signing, all that happens kind of automatically with the controller. As well as, again, the future here is you're going to be able to then bring your own CA to talk upstream to this as well. And so, again, you'll be able to bring those certs in and ensure that you have the same kind of, certificate chain throughout your whole environment. And so then you can revoke at will, if you feel like some parts of your environment's been compromised, revoke those certs in real time, and then all the communication will just stop at that point.
Okay. Any plans to use the CA authority authorization through Key Vault that we have to implement that there too?
Yeah. So we've been working really hard with the Key Vault team, really close. One of I wouldn't say it's a limitation. It's just not what Key Vault is made to do. So Key Vault is not a certificate. It doesn't do certificate signing requests.
No.
Right? Which you need in a very highly dynamic environment like this, right? So we're working close with Key Vault to kind of add that functionality to something else that it will then communicate to kind of pass off the certificate signing request once needed. Yeah.
Because today you can buy your certificates through Key Vault and you implement them like that. So that would be a solution, right?
Yeah.
Okay.
Yeah,
nice.
Cool. So now let's do the traffic split. So I'm going to deploy out this second bookstore. So there's another bookstore that opened up down the block. And then what we're going to do is this first, I'll just pause it here. So this first traffic split, you'll see here, we're still waiting all the traffic. So now we have bookstore V1 and bookstore V2, but we're still having book buyer speak exclusively just by the wait here being 100% to the first bookstore V1 service. So let's go ahead and just deploy that out, and then we'll look at the logs, and you'll see that all it's talking to is bookstore V1. And so we got that deployed, and then again, let's just tail those logs to see who it's buying books from. And you'll see the identity is just bookstore V1.
Okay.
So the next, what we're going to do is we're going to kind of do half and half. Maybe bookstore V2 has a barista, better coffee person, and occasionally they like to go there as well, right? So we're going to just split the traffic between who book buyer can talk to or purchase books from, 50-50. And so we got that deployed out. And then again, we're just going to tail the logs of book buyer to see, hey, where it's going to go buy its books and get coffee. And you'll see that it's pretty much an even split. It's going kind of back and forth, for the most case. Like if we let this run, it'll eventually even out, right? And then this last one is, hey, they didn't make this person's coffee right. Bookstore V1, they're done with them. They're taking all their business over to bookstore V2 from now on. And so this traffic split is showing you the weight of 100% going to bookstore V2. And then as we tail the logs off of who book buyer is visiting, you will see that it is all V2 at this point.
Nice.
And that's it. And so I want to give a quick update about this. So as you could tell, this was a somewhat manual process. I want to let everyone know we've been working very close with the Flagger team, and we're going to have Flagger integration here in the next couple of weeks. And so that's going to allow you to basically automate all this progressive delivery for your Canary deployments, as well as your A/B testing. So be on the lookout. We're going to be updating the Flagger documentation, as well as the OSM documentation. And so it won't be as painful as you saw here.
For those not familiar with Flagger, what is a Flagger?
Yeah. Sorry, so Flagger is an open source tool that allows you to do progressive delivery based on a number of kind of metrics or just scenarios, right? So kind of traditionally, what it'll do is it'll actually plug into a Prometheus metric store, and you can actually do some progressive traffic shifting based upon load on a certain endpoint. And then you can also say, hey, every 10 minutes move 20% of the traffic over to this other endpoint. It is a lot of configurations. We can put the link up there, but to sum it up, TLDR is it allows you to do streamlined progressive delivery in a very automated fashion based upon your application needs.
And is that a Microsoft tool, or is that just really an open source tool in the community?
Yeah, it's open source in the community. It's created by a company called Weaveworks. And so it's been pretty battle tested. It's a very popular tool to do progressive delivery. So we can leave the links or show everybody how to work with it as well.
Okay, cool.
Nice.
And that's it. So we do have another project. It's called KMS. It's a key management service that's going to allow you to bring your own customer managed keys to actually encrypt the etcd database. So just to let everyone know, like as far as the Azure platform is concerned, I mean, we do have encryption at rest, but this will allow you to also encrypt it on your side. So you have that extra guarantee of the etcd being encrypted for you with your own customer keys that you create from your HSM systems or etc. Maybe in the future I can come back on and we can kind of show that. There's a lot of work we got to do with key rotation, because that's a feature you want. You don't want to have to kind of rebuild your cluster every time you generate a new key. So we're kind of in the late stages of streamlining that whole rotation feature, and then we'll come back and showcase that to everyone as well.
Okay, fantastic. Well, that was a lot, Phil. That's not just one unsung hero. Those are a lot. But I have to say, given I touch Kubernetes almost on a daily basis, these projects really make securing a Kubernetes cluster a lot easier. So I want to not only thank the solutions, but also thank you, because for me, you're my hero of the day.
Yeah, true.
I appreciate that. Thank you. This was awesome to kind of showcase. A lot of times, people may not be aware of what we're doing, but we are. I just want everyone to know we're committed to the open source space. We're committed to working with the community, and again, we just find it super valuable to be in the open source and get that direct feedback into these projects to make sure that we're building the right solution for everyone.
No, but you are. You really are. I mean, the OSM thing, I mean, I was in love with it from the beginning, and seeing what you're doing with it now and the way you can actually cope it and that you actually sell it as a security leverage. Yeah. This is spot on, and this is the way it should be. So thank you for that. Namaste, my friend. It's pretty cool. Okay. Awesome. So I think seeing the time, to be honest, Phil, and in all honesty, you did an awesome job, but you're the longest Unsung Heroes ever. We only did 6 episodes though, but we wouldn't dare to stop you because you had so many good parts to talk about, and we would just let you do. So thank you for your time. Thank you for being with us, and thank you for supporting us. Really. Yeah, absolutely. No, I'd love to come again. So if you invite me, I'll be here. There's tons of new stuff that we got planned. So maybe when we get the new roster of new projects, I can come and showcase those as well. Yeah, anytime. Yes, that'd be great. Anytime. We'll plan that in. Okay, and on that bombshell, I think, Niels, we can say goodbye to our viewers, and we'll talk again in 2 weeks, apparently.
Yes, with another special guest.
Yes. But we're not going to talk about that yet, but it's going to be a secret. Another really unsung hero, something that not a lot of people think about. So we're going to be cool about that. Okay, bye all.
See y'all.
Thank you, everyone.